So here it says they want us to find the volume of a gram of water at its boiling point and at standard atmospheric pressure. Okay, so we need to look at P, V, N, R, and T. So my pressure is a standard atmospheric pressure. Look back at section 1.1. Pick the easiest one. Choose the one that's like gonna like not change anything when we multiply or divide by it. One. What's the unit after it?
ATM.
1 ATM. Is it 1.00?
Yeah.
Okay. So we'll pick that one. And then the volume is what we're looking for. We'll solve for liters. And then N we're going to get from converting this gram of water into moles. So you're going to divide by the molar mass of water, which is 18.02. And then that's going to end up giving you 0.0555 moles of water. The R value corresponds to the pressure unit that we have, which is ATM. So we're going to go ahead and use our 0.0821 liters times atmospheres over mole times Kelvin. And then my temperature is 100 degrees Celsius. So you've got to convert that to Kelvin. So it's going to be 373 Kelvin. Okay. From here, you can put all of the numbers into the equation. So we've got PV equals nRT. Solve for V by dividing both sides by pressure. So volume is, I'm going to leave the units out. You're going to end up getting 1.70 liters. Okay. We're going to do one more practice problem using this. Yes.
When you round for like when you do the sub calculation for like PV energy, would you round there for sig figs or would you like keep the expanded?
I think you're okay with rounding. In this case, it's such a small quantity. I don't think it's going to make a difference. Okay. Okay. So there's one version of PV equals nRT. You could be solving for P, V, N, or T. Look at number 2 at the top of the next page. Another type of problem that you might be asked to do when using the ideal gas equation is to solve for the molar mass of a gas. In this case, there are 2 steps that you will always follow. The first step is going to be to, here we are, solve for N. So in this case, it says we're at 30 degrees C. We've got our kilopascal pressure. We've got grams of an unknown gas sample. We have a volume of 3 liters. They want to know the molar mass of the gas. Okay, so that means step 1 will always be to solve for N using PV equals nRT. Okay, so if I'm solving for N, I need to divide both sides by RT. So this cancels. So that means N is PV over RT. So my pressure is 98.1. My volume is 3 liters. My R value is dependent upon the pressure unit that we have, which is kilopascal. So you're going to use 8.31. And then my temperature is 30 degrees Celsius. So 273 plus 30 is going to be what? 300? 303? Okay, so this is 303. Careful when you put these in your calculator. You may want, if you're doing it all at once, put the numerator and the denominator in separate parentheses. Otherwise, it's going to end up dividing the 3 by the 8.31. You'll get the wrong answer. You should get 0.117 moles. Okay. After this, then you are ready to do step 2, which is just a division step. So in step 2, you're going to take the grams that are given in the problem, and you're going to divide it by N. and this equals the molar mass of the gas. So the grams given is 3.26. The N is 0.117. Divide it out, you're going to get around 27.9 grams per mole. A common question that you will get is they'll ask you to identify the gas. They'll be like, hey, what gas is it? Okay, well, look at your periodic table. The gases are on the right-hand side. They gave us a hint. They told us it's diatomic. The diatomic elements are NOF and Cl. Those are the only gases because those are the only red symbols besides hydrogen, which is obviously too small because hydrogen would be 2 grams per mole because it's diatomic. Nitrogen is going to be around 28, right? Oxygen would be 32. Wouldn't this have to be nitrogen gas? Okay, so this has to be N2 gas because 2 times 14.01 is around 28. Well, 27.9 is 28, is that. Okay. Okay, last part. Let's talk about the kitty cat equation and then we're done. There is a derivation using density where they come up with an equation that helps you calculate the molecular weight, which is the molar mass of a gas. Okay, so you can only use the kitty cat equation if you have the density of the gas. Okay, again, I will not make you memorize this equation. I will give it to you. So let's take a look at the last page here. So the kitty cat equation is the molecular weight, which is the molar mass, is abbreviated as MW. It equals DRT over P. They call this the kitty cat equation because this top part looks like dirt, and that's what kitty cats put on their pee. Okay? Okay. I didn't make it up. That's just how it is. All right. Now, that's the end of section 1.2. Do you guys want to work on your homework?